We are going to do question number 7. In this question, all lengths are in centimeters and all angles are in radians. The diagram shows the circle with center C and radius R. The points A and B lie on the circumference of the circle such that angle ACB is 2 theta radians, where theta is less than pi upon 2. A part, find in terms of R and theta the perimeter of the shaded region. If we have to find out the perimeter of the shaded region, it means that we have to add up this and this. These lengths to be added up. To find out this length AB, we need to drop a perpendicular from here so that we get here right angle triangle. Now, when we dropped a perpendicular from here, it means that these two lengths are equal. If we'll take out this length and multiply it by 2, then we will get the length of this AB. We have dropped a perpendicular from here. This angle is divided into two equal parts. This is theta, this as well as theta. Now, we know that the radius of the circle is R, so we can easily find out the length from here till here, and we can say that this is point M as it is the midpoint of AB. We have this right angle triangle. This R is hypotenuse, and we have to find out this. This is opposite to theta, so this is opposite. We can apply here sine theta to find out the value of AM in terms of R and theta. So we can write here sine theta is equal to AM upon R, opposite upon hypotenuse. So AM is equal to R sine theta. So it means that the length AB is equal to 2 multiplied by R sine theta. Then we have got the length of AB in terms of R and theta. Now we have to find out this arc length AB. So AB arc length is equal to R theta. We have here R, but we have to consider this angle, right? Because we are taking out the length of major arc. So we have to find out, we have to consider this angle, and this angle would be 2 pi minus 2 theta. We will subtract this 2 theta from the sum of angles at a point, which is 2 pi. So R multiplied by 2 pi minus 2 theta. 2 pi R minus 2R theta. So now we can easily write down perimeter. Perimeter of shaded region is equal to 2 pi R minus 2R theta plus 2R sine theta. In part B, we have to find the area of the shaded region in terms of R and theta. So area of shaded region is equal to area of this triangle plus area of this major sector. For area of this triangle, we can use the formula half into AB sine theta. We have this R and we have this R, so these are the two sides, and this is angle, which is 2 theta. And for area of sector, we have formula half into r square theta. So we have area of shaded region is equal to 1 upon 2 r square theta plus 1 upon 2 AB sine theta. So when we will consider 1 upon 2 r square theta, radius is r and theta is 2 pi minus 2 theta. Then AB sine theta, AB is here, this is r and this is also r. So r square sine angle is 2 theta here. So we will write here 2 theta. If we'll multiply 1 upon 2 r square by 2 pi, we will be left with pi r square. 1 upon 2 r square multiplied by 2 theta will be r square theta. 2 and 2 will be cancelled out. And here we have 1 upon 2 r square sine theta, sine 2 theta, which is the area of the shaded region. In question number 8, the values of sine pi upon 3, cos pi upon 3, and tan pi upon 3 are already given. It is given that y is equal to tan x sine 3x. Find the exact value of dy upon dx when x is equal to pi upon 3. So if we have to find out dy upon dx, we know that tan x is multiplying by sine 3x. So we can use here product rule of differentiation. And according to that, we have to take this as u and this as v. So u is equal to tan x and u dash is sec square x. V is equal to sine 3x. For v dash, we can see that it is sine 3x. When we differentiate sine 3x, we get cos 3x. And then when we differentiate this angle, then we get 3. So it is v dash is 3 cos 3x. dy upon dx is equal to uv dash tan x into 3 cos 3x plus v into u dash sine 3x multiplied by sec square x. We have to find out the exact value of dy upon dx when x is equal to pi upon 3. So we will substitute here the value of x as pi upon 3. So tan pi upon 3, 3 into cos 3 pi upon 3 plus sine 3 into pi upon 3 sec square pi upon 3. So tan pi upon 3 is given as under root 3. This and this will be cancelled out. So cos pi is equal to minus 1. So we will write here 3 into minus 1. Then plus 3 and 3 would be cancelled out. Sin pi is 0. And 0 multiplied by sec square pi upon 3 will be 0. So we don't need to write down its value. So this will be 3 multiplied by minus 1, it is minus 3. Minus 3 multiplied by under root 3 is minus 3 under root 3. B part, it is given that x is increasing at the rate of 3 units per second. So it means that x is increasing at the rate of 3 units per second means dx upon dt is given, which is equal to 3. Find the corresponding rate of change in y when x is equal to pi upon 3. So rate of change in y means we have to find out dy upon dt. So we have dy upon dt is equal to dy upon dx multiplied by dx upon dt. We have already taken out dy upon dt in last part, where the value of x is pi upon 3. So we can simply write down the answer from there, minus 3 under root 3. Dx upon dt is 3. So it is minus 9 under root 3. Part C, find the approximate change in y as x increases from pi upon 3 to pi upon 3 plus h, where h is small. We have to find out delta y, and we require delta x, which is pi upon 3 plus h minus pi upon 3. So this and this will be cancelled out. So delta x is equal to h. We have delta y upon delta x is equal to dy upon dx. And delta y is equal to dy upon dx multiplied by delta x. So which is equal to minus 3 under root 3 into h. Question number 9. Show that 1 upon 2x plus 1 minus 1 upon 2x plus 1 whole square plus 4 upon 4x minus 1 is equal to 24x square plus 14x plus 4 upon 2x plus 1 whole square into 4x minus 1. So first of all, we have to take out LCM over here. LCM of 2x plus 1, 2x plus 1 whole square, 4x minus 1 is 2x plus 1 whole square and 4x minus 1. In the denominator of this, we have 2x plus 1. So it is to be multiplied by 2x plus 1 and 4x minus 1. This 1 is to be multiplied by 4x minus 1 because 4x minus 1 is not there in the denominator of this. Then 4 is to be multiplied by 2x plus 1 whole square. When we will expand these two, we will be getting 2x into 4x, it is 8x square. 2x into minus 1, it is minus 2x. Plus 1 into 4x plus 4x plus 1 into minus 1, it is minus 1. Minus 1 multiplied by 4x is minus 4x. Minus 1 multiplied by minus 1 is plus 1. Plus 4 into, we will expand it using identity. We'll take the square of 2x, it is 4x squared. We'll multiply 2x by 1 and then by 2. So it will be 4x plus square of 1, which is 1. In the denominator, we'll have the same 2x plus 1 whole square into 4x minus 1. Minus 1 and plus 1 will be cancelled out. Minus 4x and plus 4x will be cancelled out. We have here 8x squared minus 2x plus 16x squared plus 16x plus 4 upon 2x plus 1 whole square 4x minus 1. So finally, when we'll add these two, we will get 24x square plus 14x plus 4 upon 2x plus 1 whole square 4x minus 1. B part, hence find integral of 24x square plus 14x plus 4 upon 2x plus 1 whole square into 4x minus 1 dx. Limits are 1 and 1 upon 2. Give your answer in the form 1 upon 2 ln p plus q, wherein p and q are rational numbers. Hence find, it means that we have to use previous part to solve this. 24x squared plus 14x plus 4 upon 2x plus 1 whole square, 4x minus 1, we got in the previous part by simplifying these fractions. So we can write here 1 upon 2x plus 1 minus 1 upon 2x plus 1 whole square plus 4 upon 4x minus 1 dx. In the next step, as we know, when we have 2x plus 1 in the denominator, we can change it into ln 2x plus 1, but we must have 2 in the numerator. So, first of all, we will multiply this by 2 upon 2 so that we can write it as ln 2x plus 1. And this 2x plus 1 whole square is to be taken to the numerator. So it will be 2x plus 1 power minus 2. We have here 4x minus 1. We can change it into ln 4x minus 1. We have here 4. So we don't need to multiply it by any number. So we have here 4 upon 4x minus 1. So now we can write it as this 2 will be written here. So 1 upon 2, 2 upon 2x plus 1 will be changed to ln 2x plus 1. When we will integrate this, this will become 2x plus 1 with power minus 1. And we have to divide it by minus 1 as well as the differential of this, which is 2. 4 upon 4x minus 1 will be integrated to ln 4x minus 1. Now we can substitute here limits. So 1 upon 2 ln, when we will substitute here 1, so this will become 2. 2 plus 1 is 3, so we will have here ln 3. We can take this to the denominator. So this will become 2x plus 1 with power 1. So we already have here minus 2 in the denominator. So we will have here 1 upon minus 2 into, when we will substitute here 1, so this will become 3. So minus 2 into 3. When we will substitute here 1, 4 ones are 4 and 4 minus 1 is 3. So it is plus ln 3. minus, we have to substitute 1 upon 2 over here. So when we will substitute 1 upon 2 here, it will become 2 and 2 will be cancelled out. So we'll be left with 1. 1 plus 1 is 2. 1 upon 2 ln 2. Then minus, when we'll substitute here 1 upon 2, 2 and 2 would be cancelled out. So it will be 1 plus 1, that is 2, and 2 is to be taken into the denominator. So it will be 1 upon minus 2 into 2 plus, when we will substitute here 1 upon 2, 2 1s are 2 and 2 2s are 4, it will be cancelled out. So we will be left with 2. 2 minus 1 would be 1. So it is ln 1. 1 upon 2 ln 3 plus ln 3 will become 3 upon 2 ln 3 minus 1 upon minus 6. So it will be plus 1 upon 6. Here 1 upon 2 ln 2 will be 1 upon 2 ln 2. This will be plus 1 upon 4 and ln 1 is 0. So this is to be as it is. Now we have here 3 upon 2 ln 3 plus 1 upon 6 minus 1 upon 2 ln 2 minus 1 upon 4. We can write it as 1 upon 2 ln 3 will become the power of this, so it will become 27. 3 cube is 27. We can write minus 1 upon 2 ln 2 here, and then plus 1 upon 6 minus 1 upon 4. We will take 1 upon 2 common. So it will be ln 27 minus ln 2. And here we can take LCM. 12 is LCM. So 6 2s are 12. So it will be 2. And here it will be minus 3. Both these are 12. So 1 will be multiplied by minus 3. So we can write here 1 upon 2 ln 27 upon 2. 2 minus 3 is minus 1. So it is minus 1 upon 12. Question number 10. A particle P is initially at the point with position vector 30, 10 and moves with the constant speed of 10 meter per second in the same direction as minus 4, 3. Find the position vector of P at time t seconds. First of all, we will find out the magnitude of direction vector, which is square root minus 4 square plus 3 square. So minus 4 square is 16, 3 square is 9, 16 plus 9 is 25, so which is equal to 5. Now we have to find out velocity vector. Velocity vector is equal to the magnitude, which is given, divided by the magnitude of direction vector and multiplied by the direction vector, which is minus 4, 3. So 5 1s are 5, 5 2s are 10, so it is minus 8, 3, which is velocity vector. Now we have to find out position vector of P at time t. So position vector of P is equal to the initial position vector plus t times, time is t seconds, so t times velocity vector, which is minus 8, 3. As P starts moving, a particle Q starts to move such that its position vector at time t seconds is given by minus 80 minus 90 t into 512. Now find the speed of Q. For speed of Q, we have to take velocity vector of Q, which is 512. We will take out its magnitude. So speed of Q is equal to under root 5 square plus 12 square. 5 square is 25, 12 square is 144, 25 plus 144 is 169, so it is 30. Now C part, find the distance between P and Q when t is equal to 10. Give your answer in its simplest third form. For this, we need to find out position factors of P and Q at t is equal to 10. So, we have position vector of P as 30, 10 plus t into minus 8, 3. So, for P, we can write 30, 10 plus 10 into minus 8, 6. So, we have here 30, 10 plus minus 80, 60. So, we have here minus 50, 70, which is the position vector of P. For Q, it was already given in the question that it is minus 80, minus 90 plus t into 512. So we can substitute here minus 80, minus 90 plus 10 into 512. So we have here minus 80, minus 90 plus 50, 120. So we have here minus 30, 30. Now, to find out the distance between P and Q, we will use Pythagoras theorem. Minus 30 minus, it's minus 50, so it will become plus 50 whole square plus 30 minus 70 whole square. So we have here 50 minus 30 is 20 and 20 square is 400. 30 minus 70 is minus 40 and minus 40 square is 1600. It is 2000. They have asked to write down the answer in simplest third form. So we can break up this into 5 into 400 and we can take out the square root of 400, which is 20. So 20 under root 5 is the distance between P and Q, where t is 10.